Hi, welcome to Programming in C++. Now, in the last lecture, we looked at constructors, and we mentioned that there are different types of constructors. We looked at what is known as a default constructor, a non-parameterized constructor, a parameterized constructor, and today we want to look at what is known as a copy constructor. Okay, so the first part of the presentation will be theory. I'll just explain what a copy constructor is and all that. I'll soon show you the lesson, our lesson objectives, and thereafter we shall do a demo, okay, just to demonstrate on how we can code or implement a copy constructor. All right. Now, at the end of this lesson, you should be able to define a copy constructor. You should be able to explain what a copy constructor is, and you should also be able to describe characteristics of a copy constructor. And you should also be able to explain, and you should be able to justify the use of a copy constructor. And it is my hope that by watching this lesson, at the end of the day, I want you to be able to implement a copy constructor in C++. Okay, and just as a side lesson, I would want you to learn how to put some data input validation, okay, using mutators. So if you don't know what a mutator is, okay, you will learn about it. So let us get started. What is a copy constructor? Well, this is a special constructor, and it is used to create a new object. And this new object is actually a copy of an object which is already existing, an object which was already created. So instead of recreating a new object altogether, we simply copy an object that was already created. Now, how is this done? A copy constructor creates an object by initializing it with an object of the same class, which has been created previously. So the whole idea is to initialize a new object by simply copying an object which was already created. So what are the characteristics of a copy constructor? Well, number one, like we've just mentioned, a copy constructor is used to initialize fields of a new object by copying fields of an already existing object, and it takes reference to an object of the same class as an argument. Now, much of this will make sense as we will demonstrate by coding. And a programmer can define a copy constructor. Okay, so just like we explained about a default constructor, with a default constructor, it gets executed in the event that a programmer did not specify a constructor. So C++ compiler will do it in the background for you. Okay, so it is the same thing with a copy constructor. A programmer can either define it, or when it hasn't been defined, the compiler will implicitly define it. All right, now let us look at the syntax, or we can say the structure of a copy constructor. Now, this is how you write it. What will happen is you're going to write the class name, okay, and then inside these parentheses you're going to write this word const, okay, of course standing for constructor, and then you will repeat this class name. The class name you had here, it is also written inside it. Why are we doing that? We're trying to make a copy, and you have this ampersand and the name of the object. and of course you're going to write the code of what you want it to do here. Now this is the syntax. Again, do not feel confused about this, because it will make sense when we get into the code editor. Now, like you saw whenever we defined a constructor, in the main method we were creating objects, okay? And this is how we shall create an object when using a copy constructor. So there's a simple example here where we have an object we are creating here called B1, and we've given it the value 20, and then we want to create a second object called B2, and what we have done inside the brackets here, we've put B1. So what this means is this second object we are creating will simply be a copy of B1. Alright, so we now want to see how we can do that in C++. So in demonstrating the implementation of a copy constructor, we shall use the same example we used when we were looking at a parameterized constructor in the previous lesson. And so let us get started. We of course first begin with the header files. So we're going to define a class rectangle. Let's just create rect, and this class shall consist of the following attributes: int length and int breadth. Alright, well, we may wish to just type the words in full. Yeah. So these are private. They are private fields, but you know that by default, if we don't indicate private, by default the fields will be taken to be private, but just for the sake of making the program readable, we'll make it explicit. And then the following fields will be rather not the following fields, but the following methods will be public. We're about to define the methods. And now at this point we shall first begin by walking through the implementation of a default constructor. That is a constructor which hasn't been defined by a programmer, okay? And when we don't define it in the class, then the compiler will do it on our behalf, okay? So what we're going to do is I'll go ahead and type the different functions that we want to use to on this for the object we want to create called a rectangle. We want to be able to calculate the area, okay? We should be able to assign it the value for length. We should be able to assign it the value for breadth. So let's just do that. So we begin by creating a mutator. A mutator, this is a function we're going to use to assign values to these fields here, length and breadth. So we've made them private, and they'll only be accessed by methods which exist within that class. And that is what we mean when we talk about encapsulation and or data hiding. Okay, so we are hiding certain fields. We are declaring them to be private, but then they should just be accessed. They can only be accessed by methods which we declare public. So let us type the first such method, which we call a mutator. It is used to to assign values to the fields. So the value for length is going to be obtained by this method. Okay, and whatever this method obtains, it will be stored in the variable L, and what is passed on to the variable L will be passed on to length. Okay, so we'll do the same for breadth. We'll create another mutator. Okay, so the same thing happens here. The set breadth mutator is going to get a value. It will receive the value which will be stored in this variable B, and then it will pass it on to breadth. Now let us create a method. Let us define a method that will calculate the area. So say we'll call the method area. It goes by the data type of int, and we want it to return the value of length times breadth. Okay, so we've typed our code here, and now let us create the object. So let us do this in the main function. So now we haven't explicitly defined our constructor in this program, but yet when we call for the creation of an object, and remember, an object is an instance of a class. So a class is just a template, and what we have done here, we've defined our template to consist of these properties, but we now want to create an actual object, an actual rectangle. We shall call it R1, meaning it is the first rectangle we are creating. So how do we do that? We do that by typing the name of this class here. Okay, and here we'll state the name of the object we are creating, which is R1. Okay, and now we want to create the object for which is R1, and we're going to say R1, and upon putting a dot, there are all these objects that you can access. So we first want to set the length for this object. And what would be the length? Well, we can give it 5. And the breadth, we can call for the method that defines the breadth. Okay, we'll say 3. And let us put a cout statement here. We'll say area equals we can call for the function that calculates the area. Oh, we have not put a semicolon there. All right, so we want to create this object. Let us run it and see what results it gives. Okay, there are some errors. Let's see what those errors are. Okay, we did not close this block of code for the class here, and then we need to put a semicolon there. Okay, I believe we now do not have any issues. Let us run it. Okay, here we go. It says area equals 15. Of course, there's a more interesting way you can do it, wherein the user actually enters the length and the breadth, and we saw how to do that in the last lesson. But now our objective here is to show that the area has been calculated, the object has been created without us defining the constructor. Okay, so what has happened is a default constructor has been created by the compiler, but we can define our constructor. So let us just do that. So I'll push this text down so that we define it here. So we're going to create our constructor. We can call it that. Now this one is a non-parameterized, which I am doing, and well, in essence it does the same thing as the default constructor, because whether it is there or not, it will still give the same results. So you don't include any parameters in here. That is why it is known as non-parameterized, and it is also referred to as a default constructor. It basically works the same way as the default constructor. So you can use it to initialize the values of our fields. Okay, so that is how it will look. So if I were to run this, it will still, well, produce the same result like we had previously. It still works all right. So it just works the same as a default constructor. But let us look at how a parameterized constructor would look like. We are now going to include parameters. This will receive the value for length and another one for breadth. We'll use B for that. And we can assign L to length, and also in breadth we'll assign B. So now if we go to the main function, if we type, if we wish to create another object, let us create rectangle 2 and indicate these parameters 4 and 5, and then here we say we want to see the area for R2. Let's see what results we're going to get. So you can see that the result you are getting is for the parameterized one, because here we've stated we want the area for R2, and R2 carries these parameters, but if we put R1, it will use our default constructor here. So let's see what the results will be if we call that one. So you can see it is giving 15 because that is what was assigned to R1. Set length was 5, R1 set length was 3. Now let us define a copy constructor, and we do that by typing the name of the class, and remember the syntax. We say inside the brackets we write that word const, and followed by the name of the class again. So you see rect here, the same rect you had here, the same word, and then we put the name of the object there, R. And now let's define what this constructor has to do. Okay, so we are going to assign into length the length of this object we're going to create, the same for breadth. So now what will happen is, or what we are doing is, we are copying whatever length or breadth will be for the already existing object. And so now when we go to the main function, we want to create the third object. Let's create the third rectangle, and inside the brackets we'll put R2, meaning it will be a copy of the second rectangle. Now remember, the second rectangle has 4 and 5 as length and breadth respectively. So, and if we want the output of the area for the second rectangle 4 and 5, it would be 4 times 5, 20, and that is what it gave us when we ran it. So it gives 20. So what you see is, if we want to now print the results for the area for the third rectangle, it has to give the same result for R2 because it is a copy of R2. So there we are. And well, that is what a copy constructor does. Now I have a task for you. Now a number of these things will start making sense when ultimately we shall pick on a project to do. We shall start it from scratch, yeah, and we'll build it to completion after we've learned all the different aspects of what we are doing right now. And some of these things will make a little more sense when we start working on a simple business case and would want to develop an application for that. So now I have a simple task I want you to do. This is for your research work. and this is the task. There are generally two types of the copies that are produced by the constructor. You know, there's one called a shallow copy, and there's another called a deep copy. Okay, so these are types of copies which can be produced by copy constructor. Now I want you to distinguish between these two types. What is the difference? And number two, I want you to demonstrate and justify the use of deep copy constructor. Why is it used? So we shall have a Zoom session one of these days, and you should be able to check when that has to be done. You need to do your research now, then I'll communicate when we'll have a discussion on these two types of copies, and we'll do a demo. But before we do that, I want you to do your research. What is the difference? And if you can, try to learn how you can code, how you can implement them. Okay, see you in the next lecture.